Well, dear students, here is interesting topic on simple harmonic motion. That is motion of a ball dropped in an imaginary tunnel across the earth. Suppose here we have a tunnel across the earth anyhow, and we drop a ball here, then it will oscillate to and fro. We can prove it, and this motion to be simple harmonic. Let at an instant the ball is a distance y from point A. This is r. Now ball is at depth at distance r from center of earth. So mass of the sphere will attract. Here this is the mass m of the ball. So weight mg dash. G dash is the effective value of axial gravity at this point inside the earth. And you know that as we go deep inside, value of G again decreases. We will prove it. The motion of the ball will be simple harmonic. So here the restoring force, the force acting on this F equal to mg dash है. Component of this weight towards equilibrium point, here is it will oscillate to and fro here about point A. So that restoring force will be minus mg dash cos theta. The component of this weight will act in this direction. It will be acting as restoring force, or F dash upon m minus g sin g cos theta. This is acceleration alpha minus g cos theta y upon r. Y upon r, or alpha equal to minus g by r into y. For this point, this distance r fixed g dash upon r into y. This is constant. So comparing it with alpha is equal to minus omega square y, we get omega square equal to g dash upon r, and omega equal to under root g dash by r. And so time period of motion, t equal to 2 pi upon omega into 2 pi under root g dash by r, or you can write t barabar 2 pi under root r upon g dash. Now this g dash is equal to g m e dash upon r square. This mass of the sphere of earth m dash will be producing axial gravity, or g upon r square. M e dash, mass of the sphere, will be 4 upon 3 pi r cube rho dash. Mass of the sphere, rho is the density, mass density of earth. Mass density of earth. So we get it as g 4 by 3 pi r g into rho. If we put this value of t, g dash here, further rho further equal to also me upon 4 by 3 pi r cube also. Therefore, this t here is 2 pi under root r अपॉन g डैश. तो हमें g डैश को सॉल्व करना है. तो we put this here, g dash come out to be 4 by 3 pi r g into m e upon 4 upon 3 pi r cube. 4 by 3 pi r cube cancel. So we get here this r into g m e upon r e cube. If I put this value of g here, so g dash here, so we get t equal to 2 pi under root r upon r into gm e upon r e cube. This r cancel, and this come out to be 2 pi under root 1 upon gm upon re square into 1 upon re, or it will become, you know, this is value of g, so 2 pi under root re upon g. It is the same as the time period of pendulum of infinite length. It is the same. I have seen now, if we put the value of r and g, that time here will be given 84.6 minute है वो 0.6 minute. ठीक कर लेना. So this was the motion of, it will oscillate to and fro about with time period, this fixed time period, which is equal to time period of pendulum of large length, also time period satellite which is revolving around the earth at an angular height. Now, if number 2, if tunnel is through the center of earth, if tunnel is through the center of earth, actually these questions are never asked in class 11 exam by teachers. They don't have time, but in competitive exam such questions are generally asked. Suppose it is a sphere of earth and center tunnel is there. This is a tunnel, center of the earth. So when we drop, actually when I taught gravitation, then I discussed there also what will happen if ball is dropped here. So some told that it come to rest here because acceleration due to gravity become zero. Acceleration zero, वो है speed zero नहीं हुई है. Here speed is maximum. Like pendulum at equilibrium point has maximum velocity. So here it will have maximum velocity. Now let at any point time the ball of mass m is here at point P. So this distance is r. So restoring force acting on it F is equal to minus mg dash. Mg dash here, or F by m minus g dash alpha. But g dash here is equal to me dash upon this r square. G GME dash upon R square, or this is G upon R square into 4 by 3 pi R cube into rho. So it becomes cancel 4 upon 3 pi R cube into rho. Sorry, R into rho. So if I put this value here, this is acceleration alpha. So this acceleration alpha is equal to minus 4 by 3 pi g into rho r. Comparing it with alpha equal to minus omega square y, we get omega square is equal to 4 upon 3 pi r cube. Sorry, 4 by 3 pi g into rho, or omega equal to under root 4 by 3 pi g into rho. And time period 2 pi upon omega, so t comes 2 pi upon omega under root 4 upon 3 pi g into rho. So it looks that it is different. But you will find if you put the value of rho in terms of mass of Earth, where rho is equal to m e upon 4 by 3 pi r cube. अगर ये वैल्यू रो की रखें यहाँ पर तो क्या मिलेगा यार? You will get t equal to 2 pi into under root me upon 2 pi हम ठीक है 4 by 3 pi g or into me upon 4 by 3 pi r cube. So 4 by 3 pi r cube ये कैंसिल हो गया और it becomes 2 pi under root 1 upon GME upon RE square into 1 upon RE. Again 1 upon this is G and this is 2 pi under root RE upon G. The same. So it does not matter whether tunnel is through center or anywhere else. But the body drop in the tunnel will be oscillating with same time period. So this was an interesting topic here about simple pendulum and motion of pendulum through Earth's surface, tunnel through Earth's surface, through Earth. Sorry. Now, in next video, I will be taking more topics on the motion of pendulum, simple harmonic motion. I will be telling some numericals also. Let me have a numerical here because I have time here. Question is this: if V1 and V2 be the magnitude of velocity of particle performing SHM at distances x1 and x2 from equilibrium position. Then find the time period of oscillatory motion. V1, V2 are the distance, x1, x2. Suppose body oscillating here. This is x1, here velocity v1, and at x2 it is v2. Are the velocities, है ना? तो टाइम पीरियड निकालना है. T equal to in fact 2 pi upon omega. We need omega. Then how the velocity v1, v2 are relative with omega at distance x1, x2. I told you a formula कि v square equal to omega square into a square minus y square. While deriving expression for velocity. So v1 square equal to omega square into a square minus x1 square, and v2 square equal to omega square into a square minus x2 square. From these two equations, how to obtain omega? This is equation 1, this is 2. So subtract equation 2 from 1. Subtracting equation 2 from 1. v1 square minus v2 square equal to omega square common. This minus this करना तो a square minus x1 square minus a square plus x2 square. A square cancel. तो v1 square minus v2 square equal to omega square bracket x2 square minus x1 square. और ओमेगा स्क्वायर इक्वल टू v1 स्क्वायर माइनस v2 स्क्वायर अपॉन x2 स्क्वायर माइनस x1 स्क्वायर और ओमेगा इक्वल टू अंडर रूट v1 स्क्वायर माइनस v2 स्क्वायर अपॉन x2 स्क्वायर माइनस x1 स्क्वायर, and hence t equal to 2 pi upon omega. और t equal to comes out to be 2 pi under root x2 square minus x1 square upon v1 square minus v2 square. Time period of simple harmonic motion in which particle has velocity v1, v2 at distances x1, x2. A good question here. You can not necessarily this will be August, we will get application of formula. Thank you.